Okay, so this is the third problem from the solution stoichiometry understanding check where you had to upload your responses. So we're going to quickly go through this. Hopefully it'll help you understand it a little bit more. So what I've done is I've written the equation that you're given in the question up across the top. It's unbalanced, so we're going to need to go ahead and balance it. And then I took the information out of the question that we needed. So it tells us that we have 0.35 grams of magnesium hydroxide, and we want to know what volume of 0.5 molar acetic acid we're going to mix with that to get our products. Okay, so first thing we need to do is balance our reaction. I see here that I've got 2 hydroxides. Over here I've only got 1 hydroxide, so I took this water and broke it apart into H and OH so that it helps me balance. So I've only got 1 hydroxide over here, so I'm going to put a 2 in front. Now I've got 2 hydroxides and 2 hydroxides. And then here I see that I have 2 of the C2H3O2. And over on this side I've only got 1 of those. So I'm going to put a 2 in front of here, which works out really well because that also gives me 2 H's, which I just changed over here to have 2 H's as well. So now my reaction is balanced. My next step is to go ahead and set up the stoichiometry for it. Okay, so when I'm doing stoichiometry, I'm always going to start with the number that's kind of by itself. It's not part of a molarity, and it's not my mole ratio, even though I'm going to use both of those other things. So in this case, this is a molarity, so I'm not going to use that quite yet. But I do have this 0.35 grams that's by itself. So that's where I'm going to start. I'm going to take 0.35 grams of magnesium hydroxide. From there, I'm going to convert my grams to moles because I want to use my mole ratio to figure out how much of this I need to react with this. So my molar mass of magnesium hydroxide is 58.32 grams. Per 1 mole. Now my grams are going to cancel. I'm left with moles of magnesium hydroxide. So now I'm ready to use my mole ratio. Here I have 1 mole of magnesium hydroxide, there's no number in front, is needed to react with 2 moles of acetic acid. So 1 mole MgOH2 for 2 moles HC2H3O2. Again, now my moles are going to cancel here, so now I'm into moles of acetic acid. I can get the moles then from this molarity. So here's where I'm going to use this. I have 0.5 molar, which tells me that it's going to be 0.5 moles per 1 liter. Okay, so all I did is took this molarity and split it apart into moles per liter. I put the moles on the bottom so that I can cancel moles of acetic acid here, moles and moles. So I'm left with liters, which is technically a volume. The question, though, asked me to put it into milliliters, so I'm going to have to go one more step. It's a super easy step. All I need to do is that 1 liter holds 1,000 milliliters. So now I can cancel out liters. I'm left with my answer in milliliters. Okay. Very last step then, multiply any numbers that are on the top, divide by any numbers that are on the bottom. I should get an answer of 24.01 milliliters. Hope that helps a little bit.